Okay, here's video number 3 for section 9.3. So you've done some work with finding the sines, cosines, and tangents using points and the unit circle. Now we're going to introduce a new vocab word for you. Here we want to find the reference angle for two different angles. Now a couple things to notice. Notice the angles that we're trying to use to find the reference angles of, we're using the variable theta for. Now you're going to see for a reference angle, now every angle has a reference angle. Almost every angle has a reference angle. And the reference angle is always going to be designated by this symbol here, theta with a little comma, or a semicolon, or with an apostrophe next to it. So theta with this little tick up by where the exponent would go. So before we do this, let's go back to the journal and look at the definition of a reference angle. So if we've got an angle in standard position, the reference angle is the acute angle formed by the terminal side of theta and the x-axis. Okay, so the reference angle is the acute angle, acute means less than 90, formed by the terminal side of theta and the x-axis. So look at some examples here. So let's say we've got, here's an angle right here. It's over 90. This angle looks like it's about 110 or so. The reference angle, so here's theta right here. The reference angle is just this distance from our terminal side to the x-axis. Okay, here's another example. Here's an example where we've got an angle greater than 180, so its terminal side is in quadrant 3. So since this one's in quadrant 3, the reference angle is the distance between the terminal side and the negative x-axis. If we have one in terminal 4, it's the angle between our terminal side and the positive x-axis. So you can see right here, kind of your rules of thumb, if your terminal side lies in quadrants 1 or 2, then your reference angle goes down to the x-axis. If your terminal side lies in 3 or 4, then your reference angle goes up to the x-axis. Okay, so the reference angle is just the distance from the terminal side to the x-axis. And you can see right here, there's not just one set formula for finding the reference angle. It's not always going to be 180 minus theta. It depends on where your angle is. So, you're going to have to do a little bit of thinking, and you're going to have to, take your angle and figure out what the shortest distance to the x-axis is. So let's look at some right here. So here we've got an angle that's in radians and an angle in degrees. Let's look at the radians first. So here's 5 pi over 3. That's not quite 2 pi. So here's our angle. Okay, we take this all the way around, and it lies here in quadrant 4. So our reference angle is going to be the distance from the positive x-axis to the terminal side. Now remember, theta is 5 pi over 3. Since we know that one whole rotation is 2 pi, disregard b right now. Since we know one rotation is 2 pi, we can just take 2 pi and subtract 5 pi over 3. That gives us pi over 3. That's our reference angle. Okay? Now again, it's not going to be one equation that you use all the time. It depends on which quadrant your terminal side lies in. But it's going to be the distance from your terminal side to the x-axis. So for A, our reference angle would be pi over 3. Now for B, we've got negative 130 is our angle right here. So negative 130, here we go clockwise from the positive x-axis over 90, so it's 40 degrees past 90, and we've got negative 130 right here. So our reference angle is going to be the distance from the terminal side down to the x-axis. So here we see right now that our angle goes 40 past 90. Okay, so we've already gone 40 degrees into our quadrant. We know that each quadrant is 90 degrees. So here, because we've already gone 40, you know that 90 minus 40 gives you 50. So we've got 50 degrees left. Now, you can also, if you have trouble working with negative angles and seeing, seeing what that distance is, you could also realize that negative 130 is coterminal with 230. So here, if we were looking at 230, this would be our angle 230. That has the same side. So we can look at, this is where coterminal angles come in handy. Okay, you can look at, if a negative angle is giving you a hard time, look at the positive angle, 230. You know that you've gone past 180, so you have to subtract 180 from 230 to get your reference angle. And in this case, 230 minus 180 is 50. So your reference angle is going to be 50. Okay, now the point is, it's very easy to do. All you're doing is just finding the distance from your terminal side to the x-axis. You're either moving up to the x-axis or down to the x-axis. Okay, some of these, you might be more comfortable finding the coterminal angle and then subtracting 180. It's up to you which way works best. Okay, so again, here's how you find reference angles. Okay, you've got this page right here that shows you an example of a couple two. You can also come back here and pause it if this diagram helps you out. But the question that I want you to answer right now, I want you to find the two reference angles for both A and B right here. Now when this angle is in radians, I want you to leave your answer in radians. So if you have to type out pi with the words pi or the letters pi, that's fine. So I want you to find the reference angles for each of these. Okay? Now again, here's this diagram that you can look at right here. Now, your reference angles, they're always going to be positive, remember, because it's just going to be the distance from your angle here. So it's always going to be less than 90, and it's always going to be a positive amount. Okay? So your reference angles will be positive, and it's always going to be less than 90. So again, here's the problems that I want you to do. Go ahead and find both the reference angles and type them into the text box that pops up.